What if you could bend space and time and step across the galaxy in the blink of an eye? What if the universe had shortcuts, portals between distant places? Welcome to the mystery of wormholes. But what are they really? And could we ever travel through one? Let's find out everything we know so far. A wormhole is a hypothetical tunnel connecting two distant points in space and time. Think of space and time as a sheet of paper. Fold it and poke a hole. Suddenly, two distant places touch. This tunnel is a wormhole. The concept comes from Einstein's theory of general relativity. In 1935, Einstein and physicist Nathan Rosen proposed a bridge, now called the Einstein-Rosen bridge, that could link black holes and white holes. In theory, it could connect two different parts of the universe, or even two different universes. It's an elegant solution in the equations of general relativity, but remains purely theoretical. A wormhole consists of two mouths, the entry and exit points, and a throat connecting them. These regions would likely exhibit extreme gravitational forces and unusual space-time curvature. In most models, wormholes would need to be symmetric to avoid forming black holes at either end. However, theoretical models also include asymmetric or one-way wormholes. No wormhole has ever been detected, despite being a valid solution in general relativity. There is no observational evidence that wormholes exist. However, physicists continue to explore solutions through quantum gravity, string theory, and simulations. Some phenomena, like fast radio bursts or strange lensing events, have prompted speculation, but nothing has confirmed a wormhole yet. Wormholes would collapse instantly without something to keep them open. That's where exotic matter comes in. Exotic matter would have negative energy density, something never observed directly. The Casimir effect and quantum fluctuations hint at a negative energy on a small scale, but we don't know if large-scale exotic matter is possible. This remains one of the biggest challenges in wormhole theory. Physicists like Kip Thorne have proposed models of traversable wormholes, stable enough to allow human travel. These wormholes would require exact amounts of exotic matter and precise configurations to avoid collapse. Thorne's work in the late 1980s even inspired the movie Interstellar. But even in theory, such wormholes must be created, maintained, and stabilized, which goes far beyond current technology. If wormholes can connect not just places but times, they could enable time travel. According to relativity, time slows down near a strong gravitational field. If one mouth of a wormhole experiences more time dilation than the other due to being near a black hole or traveling at a relativistic speed, then the wormhole effectively links two points in time. But this opens the door to time paradoxes, like altering your own past. A recent idea suggests a deep connection between quantum entanglement and wormholes. The ER is equal to EPR conjecture, proposed by physicists Maldacena and Susskind, states that Einstein-Rosen bridges and quantum entangled particles are two sides of the same coin. This could unify general relativity and quantum mechanics, two fundamental theories that have long resisted reconciliation. Wormholes are a favorite in science fiction, from the film Interstellar's scientifically accurate wormhole to the portals of Stargate and Marvel movies. They often represent hope, danger, and the unknown. These stories help us explore big ideas about space, time, and reality, even if science is still catching up. Some theories propose that wormholes could connect not just regions of our universe, but entirely different universes. In string theory and the multiverse hypothesis, space may have extra dimensions, and wormholes could be tunnels through them. If true, wormholes could offer a way to observe or even reach parallel realities, each with their own versions of physics, time, and existence. So, what's inside a wormhole? Maybe nothing. Maybe a tunnel to another galaxy or another universe. Wormholes stretch the boundaries of physics and the limits of our imagination. They challenge what we know about reality. Whether or not they exist, they push science forward, inspiring us to ask bigger questions. Because sometimes the journey is just as incredible as the destination.